Hey everyone, it's Patrick. Today we're going to help 2910 with a few parts for the Mark III Mini Swerve chassis. We're here at Swerve Drive Specialties, and I'll give you a little rundown of the setup. Alright, so here we are. There's the mill itself, the side of it. Got the Mark Forged Onyx 1. So the mill is a Brother Speedio S500 X1. Around the side, that is a mist collector. Normally you'd mount that on top of the machine, but the ceiling's too low, so it goes on the side. Around the back, we've got the chip tray, which is on top of the coolant tank. So all the coolant washes down all the chips down those two chutes, and then all the chips end up in there, and then I scoop them into these bins. And I've got a bunch of these bins everywhere, and then a bunch of the bins. When all the bins are full, I take them to the recycling place. Up here, we've got a step-down transformer. These Japanese machines really like to run on like 200 to 220 volts, and we get 240 here in the US, so that steps it down, and then it goes into the phase converter, which turns it into three-phase, because we don't have three-phase in the garage. Yep. And then beside the mill over here, we have the compressor, and then down here we have an air dryer. Alright, so the mill has a 21 tool ATC, and we've got all the tools in here that we need to make Swerve modules. And on the table I've got a Pearson Workholding Pro Balance system base, and this is nice because it allows for like really quick setup changes. And the pallet base is on top of a giant, like a solid aluminum riser block, and that just gets it up, which allows these machines don't like the minimum spindle nose to table is kind of big, which is nice when you want to like fit larger things in there, like castings or something that you're going to machine. But you really want to use like super short tooling. A lot of times if you're mounting a vise or the pallet system, you need to get it up a little bit. And then back here we got the tool setter. It can also do tool breakage detection, but I'm not doing that. Back in that corner we've got the light. This machine also has this wash down system, which is nice. That'll like washes all the chips down and out. They go down and out those chutes over there. And then actually inside we've got the wash down hose, and it's inside because then like when you're done using it, it doesn't drip on your floor and stuff. It drips inside the mill. Yeah, that's another thing, part of the wash down system. Alright, so we're gonna start by cutting this 2x1 to length for these frame rails. Yeah, so I went to 2910's shop to go find some 2x1, and turns out we didn't have any new pieces, so these are actually off of our 2018 robot. I can tell because all these rivet hole patterns, and there's also these like marks where the elevator bearings ran against. So that's kind of funny. That robot is still together. We replaced all the frame with 16th inch wall, like before Chesy Champs 2018, because or not all, just the elevator frame. So this stuff was overkill and made the robot extra tippy. So we're gonna start with the the two side frame rails, which are 17.5 inches long. So I already cut this one. That one's good. Okay, so we got this piece. And I printed this little thing off on the Mark Forged. It just has little pegs that will fit into these holes. So let's mark. Do this first. So 17.5. It's like not a multiple of a full inch. So I made this thing so if you like flipped it around the other way, it would do half an inch instead of a full inch, kinda. Okay. 17.5. Like that. This is just like a pick. Cool. Looks good. Alright, so how are we going to mount this in here? So you really want like a... Hi! I'm recording a video. So we want like a vise or something in here, but we're not going to take all this stuff out and mount a vise to the table because I don't want to mess up my coordinate systems and stuff. So when we want a vise in the mill, instead of a pallet, well, we use the pallet with vices attached to it. So we're going to put this in the middle. This is definitely the heaviest pallet I have. Yep, now we're gonna have to turn the compressor on. Yep, still recording. These are 17.5 inches long. The X travel of this machine is 500 millimeters, which is like a little under 20 inches. So we do kind of need this centered kind of in the middle. We have a little bit of margin to play with. The pallet system is a little to the left, so in order to get this in the middle, travel will probably hang out a little extra on the right side. But we don't want way too much cantilever when we're machining over there. So let's see, let's move the mill all the way to the left, or all the way over this way, and see how far we can reach. And then we'll set it somewhere close to there. Alright, so that's as far as it goes. So if we do something like, maybe this way, because we do have like half holes. Okay. That's actually pretty close to the middle of those vices. Alright. And let's make this to make, so you don't have to re-0x for every single piece of material we put in. I'm going to use a drill bit as a stop inside of that hole. We'll go like that. And then we'll zero, that's okay, it's a little bit of wobble there. We'll zero against this face of the vise for X, and we'll make sure we're in the same hole every time. Looking at it too crazy because I don't want to squish this tubing. Sweet. Alright, let's get this thing zeroed. Timer. Okay. Let's do. We'll get Y0 from right in the middle there. Cool. Are we on G54? Sweet. Go. We'll touch it in a few places. See how consistent Z is off the top of this piece of frame. Off by 2 thou. This is not really, doesn't really matter that much for what we're doing. We are gonna chamfer all the edges, so it will. The exact Z height of this top surface is going to affect how our chamfers come out. Off by 1.5. That's very acceptable. Let's check all the way over here. Off by 1.2 thou. Okay. So then, we're using this face right here on the back, the fixture of the vise, to as like a reference, but I am going to put the X0 way out here. But we're not going to go off of the saw cut because it's not very precise. So we'll take like the radius of the drill bit or of the hole plus 1, 2, 3, 4 inches. So let's do some math here. Okay. All right. Okay, so let's just 0x there. Then we'll move over. 4.08. So, should look like we're pretty lined up with that edge. And it does. So if we put Y at 0 also, it's gonna look like we're right on the corner. Let's do down a little bit. Yeah, I mean, that looks correct. Okay, let's take the Heimer out. Hook back in, number 2. Sweet, now we're ready to go. We just need the program. Turn the rapids down, V-rate all the way to 0. Alright, so we finished machining the first one, just one side of it. It turned out pretty nice, so I'm going to explain how we go about doing this. So the first thing we do is drill a bunch of holes. So we drilled all these number 7 holes all the way down the part. And then to make the triangles, the first thing we did was we drilled a hole right in the middle of the triangle. So these small ones, we used a little smaller drill bit. We used this drill bit for all of these ones. This is a 3/8 inch drill. So you just drill the hole in the middle of all these triangles, and then once we did that, we drop in with this. This is a 3/16 inch end mill. So we're dropping all the way down, like really deep, taking advantage of this free space inside of the tubing, and we're dropping all the way down because then when we're machining, the effective stick out is not very much. It's only like 3/8 of an inch or something, which makes the tool really rigid and lets us take a pretty aggressive cut, even though this is a small diameter tool. So we're taking 80 thou step over. We're running at 16,000 RPMs, which is the machine maximum. For a small tool like this, we'd use 30,000 RPMs if the machine could spin that fast, but we only got 16. So we're doing 2 thou per tooth. This is a 3-flute tool, so that's 96 inches per minute. So that's going to rough out these holes pretty quick. And then, so we drop down, we rough out the hole, do all of them. Then we're doing we do a finish pass, and we're just doing that at 1 thou per tooth, 48 inches per minute, just for a nicer surface finish. And the good thing about using a small tool for this is it's gonna be able to make these tight inside corner radiuses, and also the tool pressure is going to be a lot less than if we were using a big tool, which is going to be good because the end of the tube is like hanging 4 inches out of the vise, so it's not the most rigid setup. So yeah, after we're done with that tool, then we use the chamfer tool, and we're chamfering all the edges of all the triangles and all these holes. We could backside chamfer everything, but we're not going that crazy. So we're just chamfering these outside edges. Okay, now we got to put these tools back in the machine. Being super careful, we put them in the same place they came from. Alright, so we've got the other side loaded, and we're gonna film the machining of this one. So, to film inside of the mill, this is a Luna CNC Craze 2. This is like, it's a really cool GoPro case, so the GoPro goes in, and then it's like fully waterproof, of course, coolant proof. Alright, so what's so cool about this is that there's an airline that goes in it, and then there's like an air blade that blows across this window, which blows off all the coolant. So when you're recording video, it's not just like coolant on the lens the whole time. And we got little mounts right there, this dovetail thing. Sweet. So, we're ready to do some filming. Alright, so we finished up all the frame rails. These are the other two. This one has the Jack in the Bot gesture hat, which is pretty cool. And then this one has 2910 on it. Basically the same process to make these guys as the side frame rails. And we also drilled out these holes to 1/4 clearance holes for mounting the swerve modules. At the bottom we have the access holes for getting the screws in. We did that on these too. Yeah, it's going to be a pretty small robot. So it's worth noting that I don't think we would actually do this kind of lightning on a competition bot. It's just a little more work than it's worth for us. We'd probably switch to 16th or 50 thou wall before we went this crazy, but we're just having fun on this little mini swerve bot. That's it for the video. I hope y'all enjoyed seeing what goes into making these frame rails.